So what you'll see here is that we still have the same goal, and that's to get it into this format. So don't lose sight of that. We have different parts. We have the A value that we want to bring out front. We have this K value that is a horizontal asymptote. We have this H value that gives us the vertical asymptote. So we still always want to get to that goal. A few other things about here is that you'll notice that on the top is always 1. Right here, it's always a positive 1. If it's not a positive 1, we're factoring something out to get a positive 1. Also, the coefficient of x is a positive 1. So those two things must be the same for all of these on every single problem. Otherwise, it doesn't quite come out how we'd expect. All right, so let's see here. So you'll see that we have two functions, and basically we're just going to divide the two. Right, where g of x is on the bottom, so we'll put x plus 2 on the bottom. Okay. We'll have f of x, that's on the top, 3x plus 8. So we can write that as 3x plus 8 over x plus 2. Now, of course, we're trying to get this, right, with a 1 on top. So we're starting off with 3x plus 8 on top, so that's going to be not okay. We've got to do a little bit of work. So here's what we're going to do. We're going to revisit our old friend of long division. So go ahead and divide these two. Using long division, you could technically do synthetic division as well. And let's see what we get. So x times what gives us 3x? 3. Okay. So 3 times x is 3x, switch the sign, minus. 3 times 2 is 6, switch the sign, minus 6. And then, of course, the 3x minus 3x cancels out, and we have 8 minus 6 gives us 2. So if we're doing just numbers only, like, let me just show you on the side here, just to remember this a little bit. If we had 4 into 19, actually I'll say 4 into 15, we'd say that 4 goes into 15 3 times. 3 times 4 is 12. Subtract, get a 3 as a remainder, and then the answer would be 3 and 3/4. Okay, so this 3 here and 3 over 4. 3 and 3/4. Right. We'll do the same thing here, just with all of the polynomials. So correct answer here would be 3. Right, that's our quotient. They would say plus the remainder, 2, over the divisor, x plus 2. So following the same format, and there's a plus sign here. We don't usually write that with numbers, but it's the same thing. 3 and 3/4 means 3 plus 3/4. We just didn't write it with a fraction when it's only numbers. But it means the same thing. That's why we have a plus sign here. And now, according to our format, the green, this horizontal, horizontal asymptote, we actually write it on the right-hand side. So just to adjust this a little bit for how the same format we've been doing, I'm just going to write the horizontal asymptote here on the right-hand side. So just move the 3 basically over to the other side. So the remainder part is first, and then the quotient part is second. It's kind of like if I rewrote this and I'm saying I want to write it as 3/4 plus 3 instead of 3 and 3/4. It means the same thing. It's just so it's in the same format. As we saw yesterday, we still want to have a positive 1 up here in the format. So if we have a positive 2, we want to rewrite this by factoring out the 2. Yeah. All right. So factor that 2 out, and then that will set us up to graph. So we always want this to be a positive 1, and this also needs to be a positive 1. The coefficient on the bottom of x, both of those will be positive 1s. If not, we factor them out. Like if it's a 2, factor out the 2. Now, you should be able to check this as you go. So if you factor something out, you should be able to work backwards by multiplying back in and working your way up to make sure it's correct. So if I factor a 2 out, that means this times this should equal what I have above. If not, then you just need to make sure it does calculate it right. Then we can go ahead and graph it. As we saw yesterday, this is going to be our horizontal asymptote at 3. This is going to be our vertical asymptote at negative 3. Okay. Grazie. Quick correction. Thank you. Someone noticed we went from 2 to 3 accidentally, so let's go back, make that a 2. There we go. So now we're at to the right 2. And with this a of equal to 2, and it's positive, so we're going to go up 2 over 1. So this is the a value. And we're just going to go down 2 over 1. It's always over 1. And then just get close as you can to those asymptotes without going across. And there we go. So a little bit more work. We have to do some long division. Use the quotient and the remainder and the divisor here to form the correct path that we have here. So we can get into this format. And then to make sure this is a 1, we factor out anything from the top or bottom or both to make it equal to 1 here and here. All right. So go ahead, try number 1 right here, and make sure you can work with someone as you go along to make sure it makes sense. Don't just guess and make anything up. And use the colors here. It definitely helps to have colors. Okay. All right. Using the same format here. Have 2x minus 3 here, divided by 2x minus 2 here. Do the long division. Oh, I did that wrong already, didn't I? Let's try this again. It's the second time. Okay. 2. 2x minus 2 divided into 2x minus 3. So this goes 1 time. Negative 2x. Why did I do that again? Oh my gosh. That's a 2. 2. Get positive 2. Negative 1. So we have negative 1 over 2x minus 2 plus 1. All right, please take a look up here. So this is the same in both, but you can see that we do not have a coefficient of 1 here. So you need to factor this 2 out. Divide both of them by 2, and you'll be left with x minus 1. So because this had a 2 in front, I had to factor that 2 out. So we now have -1 on top, positive 2 on the bottom, x minus 1. So the red here we need to factor out. So I'm going to pull the negative out. Right? So I'll have -1 on top, and the bottom will have a 2. So that will leave me with +1 on the inside on top, numerator, and then just x minus 1 on the bottom. So follow the colors here to see what changed. And if you're not quite sure how you did yours and if it works, you should be able to check it by multiplying it back in. If you multiply these two together, it should equal this. If you multiply these two together, it should equal this. If I multiply the 2 back in, distribute, you notice how it equals this. So there's always a way of checking as you go along to make sure everything's in the proper place. Right? So I have a -1/2, right, which means it's going to flip. So we got a horizontal asymptote of 1. We have a vertical at +1 as well. And since it's negative, I'm going to graph in these two quadrants, which are the second and the fourth. It goes 1, this is the second quadrant, this is the third quadrant, this is the fourth. So anytime this is negative, you always graph in the 2 and the 4. So we're going to go up 1/2 over 1 and down 1/2 over 1. Very close to the asymptotes. Good. So that's a compression. Anytime the A value comes out to be between 0 and 1 or between 0 and -1, that's a compression, and then otherwise it's going to be in a stretch. Okay, so small details, chances are you maybe didn't get it completely correct on there, but it's just 1 or 2 small details away from being correct. All right, so go ahead, let's try 3. It'll be pretty much the same. So 3x plus 6 and let's divide. So 3x plus 9 into 3x plus 6 divided into. There we go. Let's see here. So it looks like it'll be 1, same as before. 1 times the 3x, 3x, switch the sign, -3x. 1 times 9 is 9, switch the sign. Get -9. So this will come out to be 6 minus 9, which is -3. So we'll have -3 on top over 3x plus 9 and plus our quotient, which is horizontal asymptote. Now, you can see here, neither the top is 1, nor is the coefficient of x 1. So we'll have to fix both. We'll have to take a number out of the top here to make this a +1. And we'll have to take a number out of the bottom here and make this a +1x. So we have to do both. So you can see that 3x plus 9 is the same as 3 times x plus 3. Right? So I want to take a -3 from the top and that positive 3 from the bottom. So I'm doing a little factoring on both the numerator and denominator. Remember, if I take a negative 3 out, I have to have something here. And these two have to multiply back to what I started with, so that needs to be a positive 1. That's good. And if I take this 3 and pull that out, that's going to leave me with just the x plus 3 that I need. There we go. Good. Can we do anything else? Yeah, we could reduce it. So of course, since elementary school, anytime you saw something that can reduce, you always did reduce. So that does not change here. I still get asked every so often, do we have to reduce it? Even though the answer has never been no, some still ask it for some reason. So always. Okay. There we go. So we have a 1 here. Oops. In the numerator. And this coefficient of x is also a positive 1. Those both have to be positive 1s for this to work. All right, good. So we've got positive 1 here. Horizontal. We're going to go left 3 for the vertical. 2, 3. Once again, we have a negative, so that's going to flip. We're going to be in the 2 and the 4. Anytime that's negative, we're graphing in these two quadrants. So it's up 1, left 1, down 1, right 1. And then go ahead and draw your graph using the asymptotes. There you have it. All right, try number 2 over here. Very similar. But there is a lot going on, so as you go through it, step by step, just check with someone just to make sure everything is correct. Use the colors to help. Okay. And all right, let's take a look at our last one here on number 2. So we have our divisor, 8x, there we go, minus 12, okay. And our g of x is 2x minus 4. Go ahead and do some long division. We'll have 8x minus 12. And 2x goes into 8x 4 times. So we'll have 4 times 2x is 8x. Change the sign. 4 times 4, negative 4 is negative 16. Change the sign. Positive 16. Then we can go ahead and cancel out the 8x's. We have 16 minus 12, which is 4. So we can write our rational expression in this format with the remainders. We'll have 4 over our divisor of 2x minus 4 plus the quotient, which is also 4. Then we just have to do a little bit of factoring to get our coefficients here to be 1 on the numerator and 1 down here for the variable x. So I'm going to go ahead and factor a 2 here out, because that will give me a coefficient of 1. So let's see how this is now 1x. This will be minus 2 because 2 times negative 2 gives us the negative 4. So this 2 that I just factored out will also be part of the a value. So I'm going to factor out the 4 and the 2. So I'm going to have 4 over 2, which leaves me with a 1 on top, numerator, because 4 times 1 is 4. And on the bottom, I'll just have the x minus 2. Right? I just took out this 2, so I'm left with this part. And then still have the asymptote right here, the plus 4. And we can do a little bit more simplifying because 4 divided by 2 is 2. So we'll have 1 over x minus 2. We got plus 4. And we can go and graph this. We have a positive 4 horizontal asymptote. And we have a positive 2 vertical asymptote. Go. And we'll have to go up and down 2. Remember, it's always over 1. No matter what this number is, even if it's a fraction, it's still the rise. So we're going to go up 2 and over 1, kind of takes us off the graph here, and then down 2 over 1. So our graph should look something like this. There we go. All right. That is our notes. You can go ahead and use these and help you with the homework now.